So we're going to still stick in that same section and do some more problems on there. So we're just going to call this section P.1b. And it's still looking at those algebraic expressions. And can you guys hear me okay back there, or do I need to get the microphone out? All right. All right. So do you guys remember anything about absolute value? So sometimes we write it, you have like the little line with the X inside. Anybody know what the definition for absolute value is? Yes. Yeah, it's the positive number. And do you know why it's the positive number? Because that's what it is, right? Yeah. So technically the definition for absolute value is the distance from 0. So the distance from 0 to x, just because we got the x in there is our little variable. So what do we know about distance? Distance always has to be positive, right? And we know that distance is always positive. So why do we always make sure when we take the absolute value, we're taking the positive value? Because the absolute value is just a way of showing the distance from 0 to that number. So distance has to be positive. So if we were to figure out the absolute value of -3, what's the absolute value of -3? 3, right? Because that's the distance from 0. What's the absolute value of 5? Positive 5 or -5? Yeah, it's still positive 5, right? Because we're talking about that distance. So if we have like absolute value problems and they're written like algebraic expressions, so let's say we had the absolute value of -5 plus 3 times -2, and that's all an absolute value. So you almost have to think of like those absolute values almost as like parentheses. So you're simplifying everything inside that absolute value before you're taking that distance. So you're not going to go through and change the 5 to a positive and the 2 to a positive. You're going to simplify that as much as possible and then take the distance, right? So orders of operation, what's the first thing we would do? Yeah, so we would have -5 minus 6, right? And then we're going to keep simplifying that. -5 minus 6 is -11. Yep. And then what's the absolute value of a -11? 11. And then that's your final answer. Not too shabs. All right. You ready to draw some pretty pictures? So I got one more thing for you guys. Looking at our fancy numbering system. So if we look at our number system, there's a whole bunch of different types of numbers that we can look at. So I'm going to make a nice little big box. And I'm going to say this box are all of our real numbers. And so there's technically two very big categories of numbers. There's real numbers and there's, starts with an I, imaginary numbers, right? If they're not real, they got to be imaginary, right? And we'll get to these like way later on in the semester or the year. We're not going to focus on imaginary numbers right now. We're just going to focus on some real numbers, right? So then if we're looking at real numbers, there's a whole bunch of different little categories that these fall into. Back to our real number system. So under real numbers, we have these things called rational numbers. And a rational number, if we look at that first part of the word, that little root word, ratio, you guys know what a ratio looks like? So you can actually write a ratio almost like you can write it as a fraction, so like a over b. So any number that you can write as a number over a number is considered a rational number. Anybody got any examples of a rational number? Just say it out loud. 1 over 2. Yep. So 1 over 2 is a rational number. Anybody got anything different? Yeah, and I'm just going to throw a negative in front of it just for the fun of it, right? Negative 3 over 4, that would be a rational number. Would 5 be a rational number? Yeah, that's the same thing as 5 over 1, right? So that's also a rational number. All right. So then if we want to get even more specific, we can then drop that down to another box. And everything in this box would be considered an integer. You guys remember anything about integers, like what an integer might be? If you know an integer, you can say it out loud and I'll write it down for you. Is 2 an integer? Or you could have negative 4. Or you could have even a 0 would be an integer. So what's the difference that you guys can see between an integer and a rational number? Yes. Yeah. Right, yep. So that whole rational part of those fractions, like a 1/2 or a 2/3, that's what's taken out to be an integer, right? So an integer. Yep. All right. And then if we want to get even a little bit more specific, drop it down another level, we can go down to whole numbers. And then examples of whole numbers would be like 0, 1, 2, and 3. So can we see a difference between integers and our whole numbers? What can't we have a whole thing of? Can't have a whole negative, right? So from going from integers to whole numbers, integers are positives and negatives, and then your whole numbers are just going to be your positives. But it includes 0, right? And then our smallest little category that we talk about are what we call natural numbers. And natural numbers are like 1, 2, 3, 100, or however. So I think of natural numbers. So if you go outside and you count trees, what's the first number of trees you can count? 1, right? We don't go out to find the 0 tree and then find the 1 tree. We find the 1 tree, then 2 trees, 3 trees. So from going from whole numbers to natural numbers, you lose the 0. Not too bad. So yeah. So today, assignment, we just have kind of you guys doing some more just working with like those algebraic expressions and simplifying it. And then there's some on there when it comes to finding like the difference between the rationals, the integers, the whole, and the natural numbers. And then tomorrow, kind of like on Fridays, we're not going to go over anything new. So like on Fridays, it's always just going to be kind of like a recap of the whole week. So that way you can get ready for your quiz on Monday type thing. Sound good?